Bismillahir Rahmanir Rahim. Welcome to the lecture. My name is Abdur Rahman and my roll number is 16T22. In today's lecture, we will study the moving average filter. So let's start. Um, what is a moving average filter? Moving average filter is the easiest digital filter designed in the DSP, and it reduces the random noise and in the same procedure retains the sharpness of and the step response of the system, and it is good for time domain encoded signals and bad for frequency domain encoded. It has mainly three types, that is Gaussian, Blackman and multiple pass. So all of these are have slightly better performance in frequency expense at the expense of computation. That the performance in frequency domain is improved, though the computational cost is increased to some extent. So how do we implement our moving average filter? Moving average filter is implements operates by the average number of points at signal input to produce an output signal. That an average number of points are taken as inputs to get an output at the to produce an output of signal. So what is the basic equation that is used in average moving average filter? That is y of I is equal to 1 over m summation j is equal to 0 to m minus 1 and x subscript I plus j, where x I plus j is input and y of I is output, and m is the number of points, that how many points of moving average filter have we taken. So let's suppose we have taken a 5 point average filter and we want to get the value of y80. So we do that x of 80 plus x of 81, 82, 83 and 84 and divide it by 5. So we get the y of 80. And another type is symmetrical averaging. By doing this we can also achieve our moving average filter. So what do we do in that? We only change the limit of the our formula that we used above. That is, we take minus m by 2 to plus m by 2, and all the remaining values are same. So in that case, what is happened, that y of 80 is equal to x of 78 plus 79 and plus x of 80. We have symmetrically means that y of 80 has two values on the right side and the two values on the left side, and the value and the answer is divided by 5 to get the value of y of 80. So moving on, we have noise reduction and step response of our moving average filters. That in this we will study that how by using different points of moving average filter, what happens to our original signal. So let's suppose we have an original signal which has noise in it and we want to remove it using moving average filter. So firstly we use 11 point moving average filter. So what it does to our original signal, that our noise is reduced to some extent and the step response is the same, that is a good step response. And if we increase the number of points, that is we use 51 point, although our noise is reduced to some extent, a greater extent, no noise is found in that 51 point, but the step response is reduced to somewhat to some extent, means that as point is increased in the filter, noise is reduced and edges become less sharp, and edges become less sharp and the step response is also reduced. So another type of implementation is known as recursive implementation. So let's suppose we have a 7 point moving average filter. So in this case, if we take symmetrically implementation that was previously discussed, y of 50 is obtained like this: x of 47, 48, 49 until 43 and by 7, and you see and similarly y of 51 is taken as x of 48 plus 49 until 54 divided by 7. So we can write it as, we can also write y of 51 as y of 50 plus y of 45, that this entity is added to it, and minus 47 is reduced from the y of 50. So by doing this we can obtain y of 51. So to get a general equation, we use that y of I is equal to y of I minus 1 minus x of I plus p minus x of I plus minus q, where p is equal to m minus 1 by 2 and q is equal to p plus 1. So by using this general equation we can get our uh, output by using our previously obtained outputs, and we can consider them as inputs, and by doing so we can obtain our new outputs by using the previously obtained outputs. So by doing this, we can use the previous output as input and can calculate further output through it. So this is known as recursive implementation. So that's all for today. Thank you.